Learning limits at infinity. So here we are going to evaluate the limits by using through real life application by applying the properties of limits at infinity. Before we start, let's revise and recall these things, that how can we determine the vertical and horizontal asymptote and write their limits. Let's say the graph over here, right? So here is the graph, you can see. How can you write the limit over here? So what have you seen, that in this graph, horizontal asymptote, this is horizontal asymptote, right? Horizontal asymptote is very obvious. So we will have the two equations about the limits at infinity, which means when limit of the function x is approaching to positive infinity and the limit of the function to the negative infinity is approaching. Now look at this, here we write the y value, right? So here when x is approaching to negative infinity, what is the y value at the origin? That means here it is 0. Now from the right side, when the x is approaching to the positive infinity, again the value is equals to 0. Here in the first graph, we can't see any kind of vertical asymptote, so no need to write anything. Let's try another thing. Limit x is approaching to negative infinity and one is limit x is approaching to positive infinity. The first thing which is very clear, you have to write the end behavior, or look at the horizontal asymptote or slant asymptote and write the equation. So here it is negative infinity, right? What is the end behavior of the graph? That the graph is going down and down and down, which means it is also equals to negative infinity. When x is approaching to positive infinity, you can see the end behavior of the graph. It is going up and up and up. No horizontal asymptote it is making. So it will be positive infinity. Now in this graph, you can clearly see that there is a vertical asymptote at negative 1, right? So you can write here limit of the function when x is approaching to negative 1 from the left side and also from the right side. And for vertical asymptote, not only we write the left and right side, but we also write from the both sides. Okay, left side, this is our left side, right? Left side here, right? Because this is my left hand and this is my right hand. So left side on the negative 1, what the graph is going? The graph is going down. That means it is equals to negative infinity. Now on negative 1, where the graph is going up, it is going up, so it is positive infinity. So from the both side, the limit does not exist. If you remember, algebraically we have studied about the horizontal asymptotes and we have studied about the 3 different cases of horizontal asymptote. So according to the first case, if the degree of numerator is less than the degree of denominator, what will happen? The answer y will be equals to 0. Case number 2, we have studied that if the degree of numerator is equals to the degree of denominator, then our horizontal asymptote will be the leading coefficient of numerator divided by the leading coefficient of denominator. What is leading coefficient? So let's suppose I have an equation 4x square minus 2x plus 3, right? So what is the degree of this equation? Degree, you have to count not all the degrees but the highest degree of the equation. So this is 2. Now the coefficient which is written before the variable is said to be the leading coefficient, that is equals to 4. Now according to the case number 3, According to case number 3, degree of numerator is bigger than the degree of denominator. So it means there is no horizontal asymptote. If there is no horizontal asymptote, it means there is a slant asymptote. Whenever there is a slant asymptote, so end behavior of the graph will be either positive infinity or will be negative infinity. The end behavior, right? Let's try to solve or try to understand this horizontal asymptote by giving the equations. So first case, let's suppose that the degree of numerator is less than the degree of denominator. What does it mean? Let's suppose I have an equation 4x cube minus 9x square plus 2x minus 7 and divided by x square plus 4. Okay, so what is the degree of numerator here? The highest degree of the function is 3. What is the degree of denominator? So in this here, it is 2. So if the degree of numerator is bigger, it's, let's take the bigger equation, okay? Degree of numerator is bigger than the degree of denominator. So if it is so remember that there will be no horizontal asymptote. Okay, so no horizontal asymptote. Instead, you will have the slant asymptote. Okay, second case, if I say degree of numerator is less than degree of denominator. So let's suppose my equation is 5x square minus 9x plus 2 divided by 7x cube plus 6x square minus 4x plus 7. Okay, so in this case, what is the degree of numerator? The highest degree is 2. What is the degree of denominator? So the highest degree is 3. So you can see that the degree of numerator is less than the degree of denominator. So always the horizontal asymptote will occur at 0. Now understand the third part of this case. When the degree of numerator and the degree of denominator are equal. So let's suppose 4x cube minus 9x plus 7 and 5x cube plus 2x square plus 6x minus 1. So what is the degree of numerator for us? The degree of numerator is 3, right? What is the degree of denominator? Also 3. So in such case, what is the y value? Horizontal asymptote will be at leading coefficient of numerator divided by leading coefficient of denominator. So what is the leading coefficient? The coefficient which is written with the highest degree. So that is 4. And in the denominator, it is written as the 5. So our, our answer is 4 over 5. Now, how to evaluate the limits when there will be horizontal asymptote? So, according to the success criteria, we have to see how to evaluate the limits at infinity. When x is approaching to the infinity, it means we are talking about limits at infinity. Now, here we will see the way how can we solve, and you can just check your answer by the knowledge of the horizontal asymptote cases. What you have to do, whenever the limits at infinity are given, the first thing is that you focus on only denominator. Okay, so it means we are going to focus only on denominator. So one second, let me erase this thing. And let's check where we are focusing only on denominator. That means it is 3x cube minus 1. Okay, once you focus, you see what is the degree of denominator. So the degree of denominator, or the highest, the variable with the highest degree. Variable degree of denominator is 3. So what is the variable with highest degree? Write down the variable with highest degree. So that is x cube. Highest degree of denominator, that is x cube. So what you will do, the third step is that you will divide all the whole question divide the whole question by that variable. Okay, so how we will do it? Let's see here. First of all, we will write limit x approaches to infinity. Let me write the question to show you here. Let me write the question. Okay, now divide everything by x cube, right? Because x cube is the highest degree, right? Divide the whole question up and down by x cube. Not by the highest degree of the numerator separately and denominator separately. No, only with the highest degrees variable of the denominator. Okay, now solve. After this, solve. Now, before you solve, let me remind you one thing. If I have x power 2 and down x power 3, for example. So you know that where is the highest power? It is 3, right? So you write here, wherever you have the highest power, you minus the highest power with the other power. So highest power is down, so answer will be down. So x to the power of 3 minus 2 will be 1. On the top, nothing left, so it will be left as 1. So let's suppose if I have x power 5 up and x power 3 down. Now, where is the highest power? The 5, right? So what you will do, your answer will be on the top, because 5 position of the x with the 5 with the highest degree is in the numerator. 5 minus 3 will be 2. Okay, let's suppose x up and x power 4 down. How can you solve? Here power 1 and here down power 4. It means you have to minus 4 minus 1. That would be 3. So your highest degree will be down. So you will write x power 3. And on the top nothing. Then it will be 1. If I have x power 2 on the top, x power 2 in the denominator. Then you cancel both and the answer will be 1. So in this way, we have to solve all these questions. Let's try to remember that how we will solve this. Applying the properties of exponents. So here 3 and 3 cancel. So nothing left on the top. Only in the denominator x cube is written. Okay. Then after that, what we have here? Here x has a power 1 and down has a power 3. So on the top we will have 2, but 3 minus 1 will give you x power 2. Now this x cube cancels, so only 3 left, minus 1 over x cube. You cannot simplify more, so write as it is. Once it is done, apply the limit. The last step is apply limit. Okay, wherever you have x power 3, wherever you have x, replace by infinity. Okay, now we remember the property of the limit that 1 over infinity or any number over infinity, answer is infinity. If infinity up and the number down, then the answer is infinity. Okay, so here 1 over infinity gives us 0, minus 2 over infinity 0, 3 minus 1 over infinity is 0, 0 minus 0 is 0, 3 minus 0 is 3, and 0 divided by 3, answer is 0. We need the answer till the end. Let's try here. Let's try here. So here, look at this. What is the degree of the numerator? Degree of numerator, it is 3 over 2, right? And what is the degree of denominator? It's also 3 over 2. Okay, so now focus on the denominator's degree. It is 3 over 2. So x to the power of 3 over 2 is your variable with the highest degree. What is the other step? You will divide everything by x to the power of 3 over 2. So 5 divided by x to the power of 3 over 2. 2x power 3 over 2 as it is. Then x power 3 over 2. Then 3x 3 over 2 divided by x to the power of 3 over 2 minus 4 and divided by x to the power of 3 over 2. Now you can solve. Yes, you can solve. How can you solve? This x power 3 by 2, x power 3 by 2 cancel. This cancel. Now let's check what is left. So 5 as it is, x to the power of 3 by 2 left. Minus this cancel, so only 2 left. Down only 3 left. Minus 4 over x to the power of 3 by 2. Now simplification finish, apply the limit. So wherever you have the x, you replace by infinity. The rest as it is. Now infinity has any power, it is equal to infinity. So 5 over infinity is 0. Then 4 over infinity is 0. The rest as it is. So 0 minus 2 is minus 2 and 3 minus 0 is 3. So this is our final answer. Now try to solve this question, but before we solve, can we bring it out of the square root? Yes, we can bring it because it is so easy for us to bring it out of the square root. So what is the value of square root? It is the power half. So we have 4x to the power of half. Now focus on the denominator and write the variable with the highest degree of denominator. So that is x to the power of half. Now after that, divide the whole equation by x to the power of half. So I am first writing the question as it is. And now divide each and every term by x to the power of half. Then we have to simplify. What to simplify? The bigger power minus lower power. So 3 by 2 minus half gives us 3 over 2 minus half, it gives us 1. So we will have 5x power 1. In the denominator, this can be cancelled out. So only we have 5 minus. Here the second one cannot be solved. So we will write as it is. Now apply the limit because the simplification is done. When we apply the limit, we do not write the limit. Okay, 5 in place of x, we will put the infinity. 4 plus 1 over infinity power half. 5 times infinity is infinity. 4 plus 1 over infinity is 0. And if infinity in the numerator, then the answer will be infinity. It means whenever the answer is infinity, it means it doesn't have horizontal asymptote. Let's try one more question. Limit x approaches to infinity. 2x cube minus 6x square plus 4 divided by 7x square plus 6x minus 1. Now, see here the highest power is in the numerator, but we will ignore. We will see only the variable of the highest power with the denominator, not the numerator. So the variable with the highest power is x square. From where do we get? We will get from denominator. What we will do? Now we will write our question as it is. We will write our question as it is first, and after that we will divide all the things, all the values with the highest, the coefficient, the highest variable with the highest degree of denominator. So that is already x over 2 we found out. Now after that what do? We simplify. Highest power minus lowest power. So 2 x 3 is up, so 3 minus 2 is 1. This x power 2 cancel, and this one left as it is because we cannot simplify. This would be cancel. Now 7x over x square, it will gives us 6 over x, and this will stay as it is. Apply the limit. So wherever we have x, we will replace by the infinity. Okay. Now we know that the number over infinity is 0. So this one will go as 0. And anything multiplied by infinity is infinity. So here 7 plus 6 by infinity is 0. Minus 1 over infinity square also 0. Now if infinity up and the other are the numbers, so answer is infinity. I hope that the concept is understood to you. The main idea is that whenever any question is given to you, you focus on the denominator, select the variable with the highest degree of the denominator, divide all the terms of numerator and denominator with that variable, simplify by applying the properties of exponent to find the final x value. After that, apply the limit and then apply the properties of limit to get our final answer. Now, there is a question. Let's suppose limit x is approaching to negative infinity. What if x is approaching to negative infinity? Nothing will happen. Yani don't get scared with anything. So let's suppose 14x square minus 3x plus 6. Okay. Now, first thing is focus on the denominator variable and pick the variable with the highest degree. So in our case, it's x power 2. After that, divide the whole equation by that variable with the highest degree. Okay. So the whole thing will be divided by x square. Okay. After that, simplify. So in simplification, x square and x square cancel. Now if x on the top, x square in the denominator. So remember that 2 is bigger. So we will write the x where the 2 is written. And 2 minus 1 is 1. On the top, if there is no number, it means it will be 1. Okay, so write down the final answer. So here 4, x over x square means x, but in the denominator, as I show over here. You cannot simplify over here more. So you will have 14 minus x over x square means 3 over x, and the rest as it is because we cannot simplify. Now apply the limit. So where we have the x, we will replace by the infinity, negative infinity. Okay, whether it is in number over positive infinity or number over negative infinity, answer is 0. So we will have 4 over 14. That means 2 over 7 is our final answer. Now practice the group work, the questions given in the group work. If there is a problem, Kindly write in the chat box. I will explain those questions.